Continuous flow chemistry is widely used in the chemical and petrochemical markets and has been for decades. Recently, this production methodology has been gaining interest in the pharmaceutical industry due to the inherent increased safety, improved product quality, space savings, and overall production capacity increase. In its simplest form, continuous flow chemistry begins with two or more streams of different materials, for example, starting material and reactants, that are pumped at predetermined flow rates into a single chamber, a tube, or in some cases a microreactor, which contains very small channels where the flowing material mixes and reacts with one another. At this point, the materials mix together and react as they flow through the reaction chamber. Due to the very small size of the reaction tube or channels of a microreactor, only small amounts of materials are needed for the reaction. This dramatically reduces the amount needed for expensive compounds, lowers the solvent requirement, improves temperature control, and overall increases safety because of the lower quantity of material for potential exposure. Based on the reaction kinetics and flow rates of the material, a specific residence time within the microreactor is needed to ensure that all starting material is converted to the desired product, which in turn is then collected at the outlet of the microreactor in a flask or a container of some suitable type. Since the reaction is in a continuous flowing stream, it is highly desirable to monitor the state of the reaction to know conditions such as steady state, dispersion characteristics, reactive intermediates, and so forth. To do this requires technology that lends itself to identification of each individual reaction component, all the while in a flowing stream. REACT-IR fitted with a microflow cell is such an appropriate technology. REACT-IR is based on FTIR spectroscopy, and when coupled with attenuated total reflectance, known as ATR, it is ideal for in situ measurement and trending of reaction components. FTIR, by very nature, is specific in that each functional group of a given material has a unique fingerprint spectrum. This allows easy differentiation and determination of reaction components, and when measuring the intensity of the respective IR signal over time, you are able to trend the relative or the absolute concentration over the course of the reaction. In other words, you can watch the trends changing, and when a plateau is reached, you can be sure the reaction is at steady state. The REACT-IR microflow cell is a miniature version of a reactor with a 10 to a 50 microliter volume, whereby the flowing stream from the continuous flow reactor flows into the microflow cell, across the top of the ATR sensor, and then swiftly out of the microflow cell. The heart of the measurement happens at the interface of the ATR sensor and the flowing stream. Infrared radiation from the REACT-IR instrument travels into the sensor portion of the microflow cell, where it is directed into the diamond or silicon ATR sensor. Once inside this sensor, the IR beam is totally internally reflected and bounces through the ATR sensor until it reaches the end, where it exits the sensor and returns to the detector of the REACT-IR. The detector then measures the intensity of the IR beam. Infrared energy penetrates a very short distance into the liquid stream, and a portion of the IR radiation is absorbed by the molecules in the reaction stream. The absorptions occur in very specific regions of the IR spectrum and are completely dependent upon the type of molecule or functional group absorbing the radiation. Measurement of the IR beam that makes its way back to the detector gives rise to an absorption spectrum. This spectrum contains a fingerprint of each molecule's functional groups and/or absorption profile. This then allows scientists to identify, quantify, and trend the concentration of these reaction components over time. All this is accomplished in situ and without perturbation of the flowing reaction stream. Interfacing in situ REACT-IR with continuous flow chemistry provides a real-time video of the reaction chemistry as it takes place in the flowing stream. Instantaneous knowledge regarding the reaction parameters is inherent in this workflow. With the collection of infrared data comes the analysis of the data to transform infrared-specific information into chemical information. ICIR is a comprehensive reaction analysis software that allows users to easily identify reaction components, trend these components, observe dispersion characteristics, determine kinetics, determine reactive intermediates, and mechanistic pathways, all in real time. By trending the reaction components in real time, steady state can be determined easily and accurately. Since ReactIR is an in situ and real-time methodology, process upsets such as pump failure can be detected near immediately at the time of the failure. Ultimately, this real-time measurement ensures the highest level of information is collected about the reaction and the process. ReactIR with a microflow cell is an important tool for the detection and measurement of reaction components and reactive intermediates, their kinetics, and their mechanistic pathways. All of this is achievable during the reaction in a continuous flowing stream. Knowledge of your reaction in a continuous process stream is vital to ensure product quality, safety, and efficiency.